All right, let's dive into a topic that gives even the pros a headache: deploying real-time WebSocket apps. If you've ever built something that works like a dream on your own computer, only to have it completely fall apart in production, well, this one's for you. We're going to show you how to build it right.
I mean, you've been there, right? It's so frustrating. Everything is running perfectly on your local machine. The chat messages are flying, notifications are popping up instantly. It's just flawless. And then you push it to a live server and nothing. Just crickets. It's a super common problem, but the reason why it happens is actually way simpler than you might think.
So, here's the best way to think about it. Your little development server, that's basically a walkie-talkie. It's fantastic for talking across the room, for short distances. But production with the whole public internet, that's like trying to communicate across galaxies. For that, you need something way more powerful. You need a galactic communication relay. And that's exactly what we're going to build together today.
So what's actually wrong with just using that simple socketio.run command in production? I mean, it works, right? Well, yeah, for development. But that command is built for a quick sprint, not a marathon. When you put it out on the public internet, it hits a wall. It's not designed for the real world.
A dev server just can't keep up. It has no clue how to manage multiple processes, so if one thing fails, the whole thing might go down. Its logging is, well, it's basic, to be kind. It really struggles with handling secure connections efficiently. And maybe the most important thing, it just completely chokes the second you get more than a few people trying to connect at the same time. It's like a single-lane country road when what you really need is a 12-lane superhighway.
Okay, so how do we build that superhighway? Well, it's all about setting up the right production architecture. So let's pull up the blueprint and take a look at how the signal is supposed to travel.
And there it is, our galactic relay station in all its glory. Now, this diagram shows you the whole journey, the complete, sturdy path from a user's web browser all the way through our systems to the app itself, and then all the way back. Let's break this down piece by piece.
So the very first place any signal goes is Nginx. I want you to think of Nginx as the main docking bay of our space station. It handles every single piece of incoming traffic, it serves up static files like images and CSS, and it's our security checkpoint. It's the bouncer at the front door that decides who gets in. Okay, once Nginx gives the green light, that signal gets passed on to Gunicorn. Now this is our central comms hub. Gunicorn's job isn't to worry about what's in the messages. Its job is to juggle all of those thousands of live, open connections that make real-time communication possible in the first place.
Now, we're at the most critical make-or-break part of this entire setup. We have to get Nginx to understand that a WebSocket connection is not a normal, everyday web request. We literally have to teach it how to open a stable, persistent wormhole for our data to travel through.
You see, by default, Nginx lives in the simple request and response world of HTTP. A browser asks for a page, Nginx gets it, sends it back, and then hangs up the phone. Connection closed. But WebSockets need that phone line to stay open, and Nginx's default behavior will just slam the door shut every single time.
So how do we get around this? Well, it all happens with a kind of secret handshake. The client, your browser, sends what looks like a normal HTTP request, but it has two special headers attached, which you can see highlighted here: upgrade website and connection upgrade. This is basically the browser telling Nginx, hey, this isn't a one-and-done request. We need to switch protocols and open up a dedicated, persistent channel.
And this right here is how we teach Nginx that secret handshake. These 4 lines are the magic words. The first one just sets the right HTTP version. The next 2 lines, the proxy set header ones, are the really crucial bit. They're what actually pass that upgrade request from the client onto our application. And that last line, proxy buffering off, that's also vital. It tells Nginx not to hold on to messages, but to send them instantly, which is what gives us that real-time feel.
Okay, so our signal has made it past Nginx. Now it's hitting our application server, Gunicorn. But inside Gunicorn, we have to pick the right tool for the job, the right communications officer or worker to handle this special kind of traffic. And trust me, this choice is not optional.
In the Python world, you've really got 2 main contenders for this job: Gunicorn and UWSGI. Both of them are seriously powerful, no doubt about it. But when it comes to WebSockets, especially with Flask-SocketIO, one of them is just a much, much simpler and more reliable choice. So here's the bottom line. Just use Gunicorn. Seriously, it's designed from the ground up to work beautifully with the special asynchronous libraries that Flask-SocketIO needs to function. Now, can you get UWSGI to work? Yes, you can, but it often means dealing with complicated configurations and custom installations. For your own sanity and for a stable app, Gunicorn is absolutely the way to go.
And why is this so important? What's the big deal? Well, it's because Gunicorn works with something called async workers, like Eventlet. See, a normal server worker can only handle one thing at a time. It would get a WebSocket connection and then just stop, waiting forever for it to close. But an async worker, our special comms officer, is a master multitasker. It can juggle thousands of open connections all at once, on a single thread without ever getting stuck. This is the secret sauce for handling tons of users, and it is absolutely 100% mandatory.
So, we've built our awesome relay station. Now let's talk about maintenance. What are the common black holes that can just swallow your application whole? And, more importantly, how do we avoid them? I can almost guarantee you this is the first error you will see when you deploy a WebSocket app for the first time. A constant stream of 400 bad request errors, maybe with a little message like session ID unknown. So, what on earth does that mean?
The cause, almost every single time, is a load balancing problem. You see, the initial socket.io handshake actually involves a couple of different HTTP requests. If your load balancer, Nginx, sends the first request to one server process, but then sends the second request to a totally different one, well, that second process has no idea who you are. It's like you started a phone call with your friend, and halfway through, a complete stranger picked up the phone.
And the fix is beautifully simple. It's called enabling sticky sessions. In Nginx, you just add one single line, IP hash, into your configuration. That's it. This tells Nginx, hey, for any single user, always send their requests to the same backend server. It creates a persistent connection, and just like that, the conversation is never interrupted again.
Last thing, let's talk about being smart with security and performance. Your application code shouldn't be wasting its time and energy on encryption. That's a really heavy CPU-intensive task. The best way to do it is to let Nginx handle it. This is called SSL termination. Nginx manages all the secure WS traffic from the outside world. It decrypts it, and then it passes clean, simple data to your app over your own private, secure network. It's a huge performance boost. So let's just boil it all down to the 3 pillars of success. Number 1, concurrency. You absolutely must use an async worker like Eventlet with Gunicorn. Number 2, persistence. You have to set up sticky sessions using IP hash to keep those connections stable. And number 3, security. Let Nginx do the heavy lifting with SSL termination. If you get these 3 things right, you are golden. And there you have it. You now have the complete blueprint for building a scalable, tough, and secure real-time system. Your galactic relay is officially online. So the only question left is, what kind of amazing universe are you going to create with it? Thanks for tuning in.